Hi guys, Laurie here with the National Weather Service, and I'm going to do another experiment with you. First, let's talk about meteorology. So what does meteorology mean? It comes from the Greek word meteoron, meaning things in the air, and then ology is the discussion or knowledge of. So meteorology is the discussion or knowledge of things in the air, hence weather. Okay? I am a meteorologist, so that means that I have knowledge or schooling and I talk about things in the air, hence weather. So I look at the weather when I'm at work. I do the forecast for 7 days out for all of Eastern Washington and North Idaho. All right? So today we're going to talk about something we see a lot of in the wintertime, and it's called inversions. Now, do you guys know what an inversion is? What an inversion is, let's think about, I'm going to tell you what an inversion is not, and then we're going to talk about what an inversion is. So think about in the summertime when you go hiking. If you were to go hiking, let's say up a mountain, you would start at the bottom of the mountain, and let's say you're in shorts and a tank top and it's really warm out, and you go hiking up this mountain. And as you continue to go higher and higher and higher up this mountain, it starts to get a little bit cold, right? You start to, maybe you have to put on a hoodie, because it's getting cooler outside as you go higher and higher up the mountain. Okay, so that is what an inversion is not. So what that is as you go up higher in altitude or elevation, it gets colder, which is typically what happens. Like, for example, when you look around the mountains in the spring or fall, there's no snow in the valleys or lowlands, but you look higher up in the mountains and there's snow because it's colder in the mountains. Well, an inversion is the opposite of that. So an inversion is if you were to start hiking at the ground, and let's say it's 25 degrees at the base of the mountain. And as you hike further up the mountain, it actually gets warmer rather than colder. So at the bottom of the mountain, it might be 25 degrees, but at the top of the mountain, it might be 34 or 35 degrees. So we see inversions almost all the time here in the Pacific Northwest, but they're more prevalent and known about in the wintertime. Now, why is that? Well, it's because our days are shorter and it's harder. One of the things that kind of sometimes helps break an inversion is the sunshine, and the sun doesn't shine as long. Our days are shorter. The sun doesn't shine as long in the wintertime as it does in the summertime, right? So that's one reason why inversions are really difficult to break in the winter. So in the wintertime, we see inversions every day, pretty much. And there's two different kinds of weather regimes that we see with inversions in the winter. So the first one is days when it's cloudy and it's foggy, and the low that day might be 26 and the high that day might be 28 or 29 degrees. So there's very little difference in the temperatures, and it's foggy or cloudy the entire day. Okay? So that's an example of an inversion. Another example of types of inversions we see in the wintertime is it's completely sunny. It might be hazy to the distance, but if you look up, it is sunny. And lows that morning might be 20 degrees, and highs that day might be 32, 33 degrees. So there's a bigger variation in temperatures. But under both of those examples, cloudy with little temperature range or clear and sunny with a bigger temperature range, both of those scenarios is what happens when we get high pressure that builds into our region. And so things kind of tend to become stagnant. So what typically happens is we can see a ridge like that build into our region, and it might stick around for several days, sometimes a week, or maybe even a little longer than a week. And what happens is that warm air that's above the cold air, the warm air is trapping everything below. And so us burning our wood stoves or us going outside and making a campfire and having s'mores, or us driving our cars, or businesses, running errands and things like that, all those pollutants get released into the air and they don't have anywhere to escape because that warm air above is like a lid and it's trapping it so it can't escape. It's trying to leave and the warm air is saying, and it's coming back down and settling. So that's why when it's sunny and we're under an inversion, it might be really hazy if you look in the distance. It might be harder to see the mountains. And that's because of all the pollutants that are in the air during inversions that we see in the wintertime. Okay, so we're going to do an experiment. Are you ready? Let's begin. Okay, so let's begin our experiment. You don't need a lot of supplies. You need a mason jar with water in it, another cup or something with water in that. You need food coloring, 2 different colors, a funnel, a spoon, and some salt. That's all you need. And you're welcome to try this at home with your parents' permission. So what I'm going to do is I'm going to put some drops of red into this jar here. And I'm going to stir it up. Okay. There we go with that. Now, what I'm going to do with this jar, just for the purpose of this experiment, is I'm going to add some salt and some blue food coloring. Okay, and then I'm going to stir that up. Make sure you get the salt, make sure the salt dissolves into the water. Okay, I think we're looking good. Okay, so you can see I've got red water, I've got blue water. So what I'm going to do is I'm going to stick the funnel into this jar and I'm going to slowly pour, very slowly, pour my blue water into my red water. Okay? And then we're going to talk about it. All right, almost out. There we go. Okay. So I'm going to remove the funnel. All right. So let's see what we got here. Okay, do you guys see that? So this is an example of an inversion. So what happened was you've got warm air. Remember I said it's like a lid. So this is the lid on the cold air trapped at the surface. Okay? So this is cold air, this is warmer air. As you go up in elevation, if you were to go skiing or hiking in the mountains, you would start at a colder temperature, and as you increased in elevation, it would get warmer. Okay, and let's remember that during long periods of inversions, the pollutants that we emit, whether wood burning or you're outside at a fire pit or you're running errands in a vehicle, all those pollutants are going to get trapped in this blue layer. It's going to want to go to the red layer, but the red layer is like a lid and it's not going to let the pollutants escape. So that's why you see hazy days in the wintertime. Okay? So we've got this high pressure over us. This is what the high pressure does. It creates an inversion, makes the valleys colder, the mountains warmer. So how would we break the inversion? How would we mix it up? How would we get it to go away so that the pollutants can escape and move on and fly into the air and dilute into the air? How would we do that? Well, the number one way, the easiest way to get an inversion to break, it's something called a cold front. And it's just a change in air masses. So right now we would have high pressure over us, so kind of benign weather. But we have a cold front go through, and what happens is we'll maybe get some rain or snow ahead of the cold front. That would help because the snow falling from the sky, as it falls, the little pollutant particles would collect on the snowflake and they would drag some of the pollutants down to the ground, okay? So that's one way, but the big way is with a cold front, we typically see winds ahead of and with the front. So it might rain or snow a little bit ahead of the front, and then as the front goes through, there'll be really strong winds. Not really strong. It varies from like 15 to 30 miles an hour maybe. That's all you would need to mix up an inversion. So let's say this is your inversion. This is going to be a cold front. He's going to come on through and watch what happens when the cold front moves through. That's it. Your cold front moved through. It completely mixed up the atmosphere. It carried the pollutants away, and we're good again. All right? So make sure you guys answer the questions attached to this video, and I hope you have a good day. Thanks for watching.